Hey y'all. So like you said, I am going to talk to you about, oh, Mike, sorry. I'm going to talk about what happens when phonological phenomena affect members of different lexical categories differently. So what happens when something like aspiration doesn't treat nouns and adjectives the same, as we'll see, and how to model that. So my main research questions for this project is, how can we account for phonological variation within and across lexical categories? And does variation across lexical categories that we observe in production correlate to variation in perception of those lexical categories? And my hypotheses are that I'm going to propose a noisy harmonic grammar with faithfulness constraints that are indexed for lexical categories such as noun and adjective. And that can account for variation both within and across lexical categories. And if there is lexical or variation across lexical categories in production, then I hypothesize that we'll see that in perception as well. Okay, so just an overview. It's often been observed that many phonological phenomena do apply variably across lexical categories. So, example, Jen Smith noted in 2001 paper that nouns in particular tend to resist phonological phenomena more than other lexical categories. And we see this in Spanish S aspiration and deletion. So in Spanish, when you have a word final S, sometimes it'll be aspirated and pronounced as an H, and sometimes it'll be fully deleted in many dialects of Spanish. So for the underlying form casas, you'll have casa with an H, or the deleted variant casa with nothing at all. And the main dialects I'm going to focus on are Puerto Rican Spanish and Panama City Spanish. So this occurs more frequently on adjectives than on nouns in both of these dialects of Spanish. So here's a chart from Henrietta Cedergren's data on Panama City Spanish. You see nouns and adjectives variants. So we've got the fully faithful variant with an S, the aspirated variant, and the deleted variant. And what I'm interested in is that you not only have different production frequencies of these three variants, you have different production frequencies between nouns and adjective for the same type of variant. And I want to try to model that with noisy harmonic grammar. So just an overview of harmonic grammar. Kutsia and Pater in 2008 proposed that noisy harmonic grammar is the best model to account for in both production and perception. So in a harmonic grammar, it's much like optimality theory, where you have a set of constraints, faithfulness constraints and markedness constraints, but instead of strictly ranked, these constraints are weighted. And for each candidate, they have what's called a harmonic value. So the harmonic value is gained by adding up all of the violations for the constraints times the weight of that constraint, adding that all together, and the least offensive candidate with the highest harmonic value wins. So here's an example. We've got three constraints, max, dep, and S, star S word final, and our three candidates, books, book, and bookas. So books violates a constraint with a weight of 1. So it's a low-weighted constraint. So that has a harmonic value of -1. One constraint, one violation, times the weight, 1 of 1. Book, on the other hand, violates a constraint that with a weight of 2, so it has a lower harmonic value of -2, one violation times the weight. And what's unique about harmonic grammar is that the weights of the constraints can sort of work together to lower the overall harmonic value of each of a candidate instead of a strict ranking system. So here you have, for the last variant, bookas, you don't really see it because it violates 2 constraints, one with the weight of 4, one with the weight of 1, to get a harmonic value of -5. So it's got the lowest harmonic value. We don't see it very much. And the candidate with the highest harmonic value wins. Now with noisy harmonic grammar, there is a noise element at the time of evaluation that adds a little bit of a random component, so that if you have 2 constraints with weights that are very similar, very close together, that noise element can sometimes switch which constraint weighs the most, which will then affect which candidate has the highest harmonic value, thus producing variation in production. Now, Katsia and Pater proposed noisy harmonic grammar accounts for perception data through what they call the acceptability metric. Now, this is a formula that takes the harmonic values of two candidates and by comparing them figures out how well formed a variant should be. So here's an example for candidate X. The acceptability value of candidate X is equal to X's harmonic value minus the harmonic value of the next most harmonic candidate, candidate Y. So the greater the difference between the harmonic values of candidate X and Y, the higher X's acceptability. So if X has a high harmonic value that's much higher than candidate Y, it's going to sound much better to speakers than the next candidate. So the question then is, how can we sort of modify this to account for variation across lexical categories? Right? So I am proposing that we add indexes for lexical category to the faithfulness constraints. Now, this was first proposed by Jen Smith in her 2001 paper, and to account for why nouns tend to resist phonological phenomena, she proposed faithfulness constraints that are noun-specific. So I want to do something similar here, but apply it to a noisy harmonic grammar model so that we can get that nice variation that noisy harmonic grammar does such a good job of capturing. Okay, so Keelan Evanini did an analysis of this as aspiration and deletion, and so I'm basically just modifying the constraints that he used. So if you see here, we've got our markedness constraint there, star syllable S final, and then for the faithfulness constraints, they're indexed for noun versus adjective. So this allows the model to treat nouns and adjectives differently, which is how we can get that variation across lexical categories. So I wanted to test this and see if I could get an artificial learner. Oh, so here's, before I get to that, here's what those tableau would look like. So this first tableau, sorry, it's a little bit blurry, but you've got the candidates, the variants for libros. So you've got the aspirated libro, and you've got the fully faithful libros. So here you see star S syllable final, our markedness constraint, and then you've got the noun-specific faithfulness constraint there. And notice the adjective-specific faithfulness constraint is blocked out. It's not activated. It's just sort of dormantly lying there. It's not applying here. But the noun-specific and the markedness constraints, those are applying. And down here for buenos, the adjective, we see the same thing. Now here, the noun-specific faithfulness constraints are blocked out. They're not applying. They're just sort of dormant. And the adjective-specific faithfulness constraint is there. Okay. So I wanted to see whether this model could produce the production frequencies that Cedergren observed in Panama City Spanish. So I tested it in an artificial learner in Prot. I inputted this grammar. And to mimic learning with a noisy harmonic grammar model, I implemented a linear OT decision strategy, which made it so each violation of a candidate negatively affected the harmonic value of each candidate. I ran it for 100,000 learning trials, and according to the advice of Pater, the markedness constraint was given an initial weight of 100. It was ranked very high, or weighted very high, excuse me. And the faithfulness constraints were given an initial weight of 0. And then as they learned each learning trial, they would rearrange those weights to closer approximate the grammar that it was trying to learn, until the weights finally stabilized. And what we see, after 100,000 learning trials, the artificial learner in Prot produced these frequencies for each variant, noun and adjective. Okay, so here in the middle is what we predict based on Cedergren's data. This is what actually recorded people producing in Panama City Spanish for each variant. And the learner in Prot learned very, very closely. So where we expected 11% for the fully faithful buenos, we got 9.69%. Where we expected 41% bueno, the aspirated variant, we got 42.05, and so on. So it was extremely close. So the artificial learner was able to learn the grammar with these constraints that were indexed for lexical category. Okay, so far this model seems to be doing pretty well for production, but what about perception? Can this account for perception that native speakers have of these variants? And I couldn't find any perception data, so I decided to collect some. So the predictions that what I was trying to see, if we plug in the harmonic values of each candidate that we get from the model into Katsia and Pater's acceptability metric, we get these predictions for well-formedness for each candidate. So the buenos, the fully faithful adjective, should be the least well-formed, followed by libros, should be a little bit better, the fully faithful noun. And then the aspirated noun should be better than the fully faithful, and the aspirated adjective should be best of all, based on the acceptability values for each candidate. So I wanted to run some experiments and see if that's in fact what native speakers judge the case to be. Is this how they actually are perceiving these variants? So for the first experiment, I wanted to see if the acceptability values for each candidate accurately predicted how well formed they were. And the hypothesis is if this model is correct and if Katsia and Pater's acceptability metric works, then aspirated adjectives should be more well formed than aspirated nouns. And I decided to test this on Puerto Rican Spanish speakers because there aren't a lot of Panama City Spanish speakers in North Carolina where I am, but there is a very large Puerto Rican Spanish population, and their dialect has the exact same sort of distribution of these variants as the Panama City Spanish. So even though the actual, acceptability values might be a little bit different in Puerto Rican Spanish, the overall scale should still be the same. The aspirated nouns should still be less well formed than the aspirated adjectives. So for experiment 1, each participant listened to a series of pairs of lexically identical sentences. So they had the exact same words in them. But in one sentence, the aspiration occurred on the noun, and in the other sentence, the aspiration occurred on the adjective. And then they were asked to choose for each pair, which one sounds best to you? Which one do you prefer? Okay. So here's just an example of a pair of sentences, and I'll see if I can get it to play. Oh, not playing. That's okay, I can read them, but please excuse my accent. So they would first hear, hablaremos con viejos profesores mañana, and then they would hear, hablaremos con viejos profesores mañana. Which one sounds best? And they would choose. So in a forced choice, if you had to put aspiration on either a noun or adjective, where are you going to choose to put it? And here are the results. So for all 7 participants, they generally favored putting the aspiration on the adjective over the aspiration on the noun, which is what the acceptability metric predicted. And in a statistical regression of all the different variables, I had a lot of controls. I had an equal number of post or pre and post nominal adjectives used. I had an equal number of feminine versus masculine, etc. A lexical category, noun versus adjective, was the only statistically significant variable in their decision making. So this got me kind of curious. Why, if you're violating the same type of faithfulness constraint to get this aspiration, why is it that you prefer to do that with adjectives than nouns? So I ran another experiment with the same participants. And the research question here was, does the lexical category of a word affect how native speakers actually categorize that fricative, that word final fricative, the aspiration, versus the S? And my hypothesis is the more well-formed the variant, the less the violation of faithfulness will be perceived. You don't notice a rule that's broken all the time, but you notice when a rule is broken that people usually follow. It's sort of the thinking here. So the methods here, the participants were listened to just one word at a time, and either an adjective or a noun. And each word had a fricative spliced onto the end that was created to be more or less H-like. So what I did was I took an H and I took an S. And using a formula in Pratt, I created a series of artificial fricatives in between H and S so that the fricatives gradually got more S-like. Okay. And so I eventually had a continuum, H, gradually getting more turbulent all the way to S. And I put those on the ends of adjectives and nouns. And they listened to one word at a time, and they were asked, do you hear an H or an S at the end of this word? And they had to choose. And as we see, well, we're not going to get to play these, but yeah. So as we see, they perceived the sounds differently on adjectives than they did on nouns. So the lexical category actually affected how they heard that word final fricative. So here, these graphs, we've got the fully faithful H down here, gradually getting more S-like until we have a full S over here. And for the same sound, let's say 70% H that had a little bit of 30% S in it, on nouns, they've classified that mostly as H. Most of the time they heard that as an H. They said they heard that H. But on the same sound, on adjectives, most of the time they said they heard an S, even though they're hearing the exact same sound. So the lexical category is not only affecting how well formed they think these things are, they're affecting how they categorize those fricatives in their minds as H and S. The threshold between when you go from an H to an S is different for adjectives than for nouns. And once again, lexical category was the only statistically significant variable in this experiment. So conclusions that I found, lexical category does play a role in both production and perception of phonological phenomena. So if we're going to have a phonological model, it has to be able to look and see what the lexical category of the candidate is. Okay. If you're going to treat nouns and adjectives differently, you have to know when you're dealing with a noun and know when you're dealing with an adjective and have a mechanism for dealing with them separately. And noisy harmonic grammar text faithfulness constraints can account for both of these things. It can account for the production and it can account for the perception across lexical categories. And experiment 1 showed us that the greater a variance acceptability, the more well-formed it is. And experiment 2 showed us the more well-formed a variant is, the less likely the native speaker is going to notice a violation of the faithfulness constraint. They're going to categorize that differently. So further research, I'd like to run this on more participants. I only had access to 7 for this study, and I would like to get more participants, both Puerto Rican Spanish and other dialects of Spanish that show this variation. And I also would like to test this model on other instances in other languages of variation across lexical categories to test exactly how cross-linguistic this is. Okay. Thank you. Okay.
Okay, we've got about 10 minutes for questions.
Hi, this was great. I'm not used to the word aspiration being applied to things that aren't voiceless stops, so I wonder if you could just very briefly describe the main differences between the S sound and the H sound as realized. Is it simply the frequency of the turbulence, as one might suspect? Were there also, if you did a production study or did Settergren report, were there duration differences, intensity differences one might assume between an S and an H? Is this simply S and H, in just very briefly?
Yeah, it is S and H, and I was actually kind of hesitant to use the word aspiration for that very reason, because I'm used to aspiration being a puff of air at the end of a stop or something. And there is actually such a thing as an aspirated S that's kind of different. But that's just the terminology that people who have studied aspiration and deletion, that's just what they use. So Keelan Evanini, Henrietta Settergren, it's just, I was keeping with the terminology that they used. It is a case of just S versus H. So, yeah.
Okay, I had 2 questions, and if somebody wants to jump in, these are just sort of clarification questions. A lot of this is kind of new for me. But my main question with the model that you're using, the noisy
Harmonic grammar.
Noisy harmonic grammar.
Yeah.
You have this sort of percent, there's this chance that one rule will apply over another.
Mm-hmm.
This percentage, can we understand this is for how do we understand what is this percentage? Is this just variation that exists within a community, or is this actually like language change and happen? So we're seeing that maybe for the varieties of Spanish you observed in the past, they had maybe only S,
Mm-hmm.
and now we're seeing S aspiration, and so in the future we're not going to see S, we're only going to see aspiration. Or what? How can we understand this sort of percent?
So by percent, you mean the
This
percentage observed?
Basically, this chance of, oh, maybe this will happen or maybe that will happen in the realization or perception of these tokens.
Yeah. So it has been put forth that maybe this is a sound change in progress in these dialects, and some dialects of Spanish have a lot more aspiration than others. So the ones that I was looking at had the same sort of degree. So these right here, these are actual observed frequencies of production of those. So in regards to the grammar, the likelihood of one variant occurring versus the other has to do with the weights of the constraints that they're violating. So, for example, here, you get a lot more production of the aspirated variant than you get of the S, but these are closer together, the aspirated variant and the fully deleted variant. So in the model, the constraints that are responsible for determining am I going to aspirate or am I going to delete, those weights are much closer together than the weights of the constraints that determine am I going to get an aspiration or am I going to get a fully faithful. So the closer weighted the constraints are, the more likely they're going to be to switch. So you get much less production of the fully faithful because the weight of that constraint is a little bit farther away than the weight of these two constraints to each other. Does that answer your question?
Yeah.
Okay, good. Yeah. Yeah, it will be interesting to see how this sort of evolves in these different dialects. Yeah.
I thought the sound study is really interesting, especially that it's the same sound that got different characterization. So I was wondering, there are actually, even starting from the early days of categorical perception, the report has been showing all kinds of factors affecting the perceptual boundary between the two sounds within the same speaker, within the same language. I was wondering whether adjective, those report didn't say that there could be a different sound boundary in nouns and adjective, but your study seems to suggest that people's perceptions of nouns and adjective, or especially people's tolerance of variations, are different in these two categories of words. So I wonder whether that could be possibly explained as a different boundary of categorical perception for nouns and adjectives.
Could be. Yeah, I'm not very familiar with the categorical boundary studies, but yeah, that's something I could look into further. Yeah, it could be a different boundary for sounds.
Me again. And I know that your presentation is focused on modeling how these are different, but I'm wondering if you're willing to speculate as to why. If nouns are different than adjectives, is the answer just because? Is it that nouns have started a sound change that adjectives haven't followed on? Is it the lingering morphology somewhere? Why? Do you have any ideas of why this would be the case? Just even explaining this table.
Yeah. That's actually a really good question, and it's one I don't have a concrete answer for. But one thing that has been observed cross-linguistically, and these two papers by Jen Smith do a good cross-linguistic analysis of variation across lexical categories, and it just seems that nouns in general, cross-linguistically, tend to resist phonological phenomena more than other lexical categories like adjective and verbs. And I'm not sure why exactly that is, but there does, all across linguistics, nouns seem to have sort of a specialized place. And I'm not sure what it is about nouns. So someone in cognitive linguistics might be able to answer more to that than I can. But nouns do, cross-linguistically, just tend to act differently. They sort of go in their own way. And I'm not sure why, but hopefully one day we'll know.
Frequency effects is a big factors for sound change.
Right.
So there's the lexical diffusion theory, and there's Jackson is here. Pathaniyogi wrote a book on calculating when sound change will happen based on frequency information. The Spanish data are actually involved. It's actually predicting, for example, the change of the pronunciations of J in English. J is a very low frequency sound, got invaded by a high frequency Spanish J pronunciations as ha, so you say Jose. To the extent that it will invade the Indian name Rajan, and people would say Raham. So those are the frequency of sound. So I was wondering whether, and he has very detailed predictions, like when the frequency percentage, then the sound change would just take over. Like it's exponential change after a while. It takes a long time to build up to the threshold. After they pass the threshold, it would just take over. If I remember right, it's something like 15 to 25%. I wonder Jackson knows that, because I know John Goldsmith knows that. Okay, and so he didn't come here, so I can't verify that that number. So I was wondering whether now, and it is likely that noun and adjective have very different frequency distribution. So that I don't know the model detail enough to immediately plug in and give you a predictions, but I would just say it's probably worth investigating through that model.
Yeah, I'm not sure about the exact frequency of nouns in general versus adjectives in general, but that is something that I was very aware of when I was designing experiment 1. So for each pair of sentences, the nouns and the adjectives in each sentence, using a Spanish frequency dictionary, had the same lexical frequency. So viejos and profesores had the same lexical frequency, and they were in the same sentence. So I do know that it's not that they were choosing to aspirate the more frequent of the two, for whether it was the adjective or the noun, because I did control for that, but in terms of adjectives and nouns in general, I'm not sure. But that could be why it's applying more to adjectives in general.
I think that this theory speaks really nicely to multi-channel theories in general, which often have kind of a predictability component to them. So it may be that because of properties of Spanish in particular, that the adjectives are more predictable than the nouns, which have more flexibility in being able to understand what's going on with them. So that could be a possible mechanism. But I don't know, it's very cool. So
yeah, that's one reason I kind of want to go to other languages too and test it and see if it's
awesome.
Yeah. Okay, thanks.